Hello, everybody. My name is Muneera Altayeb. I'm a lecturer at Al-Ahliya Amani University in Communications and Computer Engineering Department. Today, I'm going to talk about our latest research submitted to International Journal of Electrical and Computer Engineering under title Detection and the Classification of Pneumonia using the Orange3 data mining tool. This research done by me as a first author and by a good contribution of my colleagues Areen, Arabiat, and Professor Amani Al-Ghraibah. Let us take a look about or on outline of this presentation, starting from introduction, then literature review, novelty, methodology. In methodology, we will discuss proposed model, dataset, feature extraction, and classification methods. And finally, we will discuss results and conclusion. Introduction. Why did we choose this particular disease? Because pneumonia is one of the most dangerous types of infection that affect one or both lungs. The main cause of this disease is infection resulting from bacteria, fungi, or viruses. When the clinical signs are identical, it's difficult to differentiate between the forms of pneumonia and whether it's COVID-19, bacterial pneumonia, or viral pneumonia. Therefore, X-ray diagnostic imaging technique have become one of the most accurate methods for distinguishing between the vital sign of the type of pneumonia infection. However, this technology requires doctors and experts to diagnose and detect the disease in its early stages. Therefore, the importance of artificial intelligence and machine learning has emerged in the field of accurate diagnosis of this type of disease. Literature review. In the last few years, researchers have employed deep learning, artificial intelligence, and machine learning to analyze chest X-rays to enhance the accurate diagnosis of lung disease. The table below shows some of the studies in the literature that were addressed in our research. In 2020, Darcy and his colleagues introduced a model based on ensemble learning and CNN, and the accuracy was about 95%. Then in 2022, Areen and his colleagues introduced another model based on VGG16 and residual neural network 50. And the accuracy was about 98.8%. In 2024, Minshawi and his colleagues presented a model based on XGBoost and AdaBoost, and the classification accuracy was about 94% and 96.2% respectively for both algorithms. Al-Shinnawi and Ibrahim in 2020 presented a model based on long short-term memory and residual neural network, CNN, and mobile neural network, and the accuracy was about 99.22%. Al-Muazzez in 2023 introduced a model based on CNN and AdaBoost, and the accuracy was about 94.5. Finally, She and his colleagues in 2023 presented a model based on CNN and long short-term memory, and the accuracy was about 90%. Novelty. What is the novelty of our work? The novelty of our work lies in using a unique and different model, combining the Orange3 data mining tool used to build several classification models and MATLAB to extract features from chest X-ray images in an innovative way that relies on performing several pre-processing steps. Then the images are converted into signals to extract MFCC features, which are used to train the basic classifier. In this work, adaptive boosting, decision tree, gradient boosting, and random forest. Methodology. The primary phases in this study began with extracting MFCC features from the dataset of chest X-rays images, which consist of different categories: normal and viral pneumonia, bacterial pneumonia, and COVID-19 cases, after applying image processing using MATLAB to improve the quality of features. Then utilize the features group to develop an automated model using Orange3 data mining tool, which classifies the input data as normal COVID-19, bacterial pneumonia, or viral pneumonia. In this work, the dataset was divided into two groups, 70% as a training dataset and 30% as a testing dataset. Figure 1 shows the structure of our proposed model, starting by the dataset. And the dataset consists of 4 categories: normal, bacterial pneumonia, COVID-19, and viral pneumonia. Then the pre-processing and image enhancement using MATLAB. It's the first step of this classification model. Then the MFCC feature extraction done to extract the MFCC coefficient, and this feature then will be used as input to fed the classification model. The classification model is based on AdaBoost, random forest, gradient boosting, and decision tree. The final step in this research is how to evaluate our classification results. Then we have a classification result and performance evaluation. The performance evaluation done using confusion matrix based on accuracy, F1 measured, recall, and precision. In figure 2, we can see the graphical user interface of Orange3 data mining. Here we can see the basic classifier, decision tree, AdaBoost, gradient boosting, and random forest. On the other side, we can see the evaluation technique, ROC analysis, confusion matrix, and predictions. Here we can see a sample of confusion matrix and the result of evaluation for the 4 algorithms based on accuracy, area under the curve, F1 measured, recall, and precision. The dataset. In this work, we use an open source Kaggle dataset. This dataset consists of 4,800 chest X-rays. There are 4 categories in this dataset: normal and COVID-19, bacterial pneumonia, and viral pneumonia. Feature extraction. Feature extraction is the process of extracting the visual component of an image, which in turn contributes to the image analysis and classification process. There are many methods to extract features from images. And this work relies on a set of image pre-processing operations using MATLAB, such as threshold, charming, and applying several enhancement techniques, include the median filter and Pruitt filter, to improve the extracted features. In the next step, the enhanced images are converted into one-dimensional signal, after which frequency-dependent features are extracted using the MFCC features. In this work, the signals is divided into a set of overlap frames, depend on the depend on the frequency details of each frame, and the number of samples per each frame is 2,000 samples. We can see the basic steps of MFCC feature extraction in figure 4, starting by pre-processing, a step to enhance the image, then convert the image to one-dimensional signal because MFCC feature depend on the frequency of the signal. So we need to convert image into signal. Then framing, as we said before, in this work, we split the signal into 40 frame, and the number of sample per each frame is 2000 sample. After that, we applied Hamming window. The main role of Hamming window is to smooth and improve the starting and the ending of each frame. Fast Fourier transformation of the resulting signal done, followed by Mill filter bank. Mill filter bank done by taking the logarithm of all filter bank energies to generate Mill frequency coefficients. We can do it using the most popular formula described in equation 1. The final step in MFCC feature extraction is take the inverse fast Fourier transformation. Finally, we get the features or MFCC coefficients. Classification methods. Classification and pattern recognition are one of the crucial functions in data mining and machine learning. In this work, the classification model was created using data mining tool Orange3, where several supervised and unsupervised classification methods were used, starting with adaptive boosting or AdaBoost. The AdaBoost algorithm is an ensemble method that combines the training of several weak classifier based on supervised learning method to produce a robust classifier that optimally separates positive and negative situation. And this kind of algorithm or technique are commonly used in medical image processing and classification of disease with respect to image. The second one, decision tree, is a supervised learning method used to classification and regression. It trains a given sample when the outcome is already known. Gradient boosting, using an appropriate cost function. Gradient boosting is a machine learning approach, trains several weak classifiers such as decision tree by integrating more trees and resolving faults in its prior-based model. The gradient boost tree approach can increase prediction accuracy to produce a robust model for regression and classification tasks. Finally, random forest. The random forest is the tree predictor step used for unsupervised learning. Regression and classification, it is a modified form of bag trees. It employs branches of random data and randomized regression trees, and it's based on binary decision trees and an ensemble classifier system. The out-of-bag OOP data is used by the algorithm of assess general faults, the quantity of terminal nodes, trees, and variable required for random forest development. Results. In this work, the efficiency of the proposed model was examined using confusion matrix based on F-measure accuracy, precision, and sensitivity, and recall. As shown in table 2, several algorithms were used to classify chest X-ray images, including AdaBoost, decision tree, gradient boost, and random forest performance evaluation. For each algorithm is carried out using confusion matrix. What can be observed from these results is the AdaBoost excelled with a classification accuracy of 100%, while the classification accuracy of random forest reached 99.5%, followed by gradient boosting and decision trees with the classification accuracy of 98.5%. and 97.2% respectively. On the other hand, it can be observed that the AdaBoost outperforms all classifier by 100% for all performance metrics, accuracy, precision, sensitivity, and F measure as shown in Table 3. Conclusion. This work reviewed and tested several classification methods for detecting and classifying pneumonia based on 4,800 chest X-rays images obtained from Kaggle. This study relied on using MATLAB to extract MFCC features from images. After that, the classification model was built from 4 basic classifiers: AdaBoost, decision tree, gradient boost, and random forest, based on the data mining tool Orange3. The result demonstrates the effectiveness of the feature extracted from images in classifying X-ray images into 4 categories: COVID-19, bacteria, pneumonia, viral pneumonia, and normal chest. A comparative analysis was performed to find the best classifier among the 4 techniques, and the performance comparison reveals that the AdaBoost classifier obtained the best accuracy of 100%, followed by random forest, gradient boost, and decision tree with accuracy of 99.5% and 98.5% and 97.2% respectively. Thank you for your attention, and please contact me to know more further information about our research. Thank you. About 90%.